This is the second layer in the IoT processing architecture, that is the edge layer. It is also called as the local processing. Now here the edge layer, it lies between the sensing devices and the cloud, and here the data is processed close to where it is generated, that is using the nearby computing devices instead of sending everything to distant servers. Now here the data which is received from the sensor, it is processed locally, and only important or filtered data is forwarded to the higher layers, that is to the fog or the cloud, and some real-time decisions can be taken instantly. In simple words, you can say this layer acts like a local brain that responds quickly without waiting for the cloud. Now examples of this layer are of the edge layer are, the first one is a Raspberry Pi, which is a small affordable computer used for edge processing. It can run programs to analyze the sensor data, perform image processing, and control the devices. And the role of this Raspberry Pi is to process the data locally, like detecting the motion from the camera feed, and it sends only the relevant alerts to the cloud. Then second is a local server in a building, where a dedicated computer system is installed within a home or the office or any campus, and it collects the data from multiple IoT devices in that location. And the role of this local server is to perform the bulk local processing, and it stores the temporary data, and it handles tasks like security monitoring, energy management, and so on. And it reduces the need to send all the data to the remote servers. Then comes the smart gateway, which acts as a bridge between the IoT devices and the internet, and it connects the devices using the protocols like Wi-Fi, Zigbee, or the Bluetooth. And the role of this gateway or the smart gateway is to filter and aggregate the data, and to convert the data formats, and also to perform some basic analytics. And it ensures only useful data goes forward. Then comes the fourth example, that is the mobile phone. Like a smartphone can also function as an edge device, especially useful in the wearable IoT systems, and the role is to process the data from devices like fitness bands, smart watches, and it displays the real-time insights to the users. So here your phone calculates the daily steps instead of sending the raw data to the cloud. So the purpose of the edge layer is fast response. That is because the processing is done locally, there is no need to wait for the cloud communication, and immediate actions can be taken. For example, a motion detector triggers an alarm instantly. Second is the low delay, that is the latency, that is the time taken to process and respond. Here in edge processing, it reduces the delay because the data travels shorter distance. For example, in autonomous vehicles, the decisions must be made in milliseconds, so there it can be used. Then comes the less internet dependency, where the devices can function even with slow internet and no internet also in some cases. For example, a smart home system, it will work locally during the internet outage. So here one real-time or real-life example is about the CCTV camera. So it captures the videos continuously, and instead of sending the full video to the cloud, it sends only the data to a local edge device, that is a computer or the server. And at the edge layer, motion detection algorithm will run locally, and it identifies the unusual activity and sends only alerts or short clips to the cloud. And the benefits here are, it saves the bandwidth, and it has a faster response, and also improved privacy, that is less data is shared online. So the edge layer, it focuses on the process nearby, respond quickly, and send less data. So this makes the IoT system faster, more efficient, and more reliable. So this is about the second layer of the IoT processing architecture, that is the edge layer.